In this question, you're given that x is a times theta minus sine theta, y is a times 1 plus cos theta. You're asked to find d square y by dx square, the second order derivative. So first what we do is, let us find dy by dx. So because it is both are in the parameter theta, I can write as dy by d theta by dx by d theta. So what is dy by d theta? A times 1 plus cos theta's differentiation is minus sine theta, divided by a times theta minus sine theta's differentiation is 1 minus cos theta. So a and a gets cancelled. You get minus sine theta by 1 minus cos theta. So you can do further simplification. So sine theta can be written as 2 sine theta by 2 cos theta by 2 divided by 1 minus cos theta is 2 sine square theta by 2. So 2 and 2 gets cancelled. Sine theta by 2 and sine theta by 2 gets cancelled. You get minus cot of theta by 2. This is dy by dx. Now, what is d square y by dx square? So remember the concept that we have seen. We have seen that dy by dx will be in terms of the parameter. So here parameter is theta. You can very clearly see that dy by dx is in terms of theta. So d square y by dx square is nothing but d by dx of dy by dx. But dy by dx is in terms of theta. So what I do is d by d theta of dy by dx divided by dx by d theta. That is equal to, so whatever dy by dx you get, differentiate it with respect to theta. So minus cot theta by 2's differentiation is minus of cot theta by 2's differentiation is minus cosecant square theta by 2 times 1 by 2 divided by dx by d theta is extra. So what is dx by d theta? A times 1 minus cos theta. So minus and minus gets cancelled. So the answer is cosecant square theta by 2 divided by 2a times 1 minus cos theta can be written as 2 sine square theta by 2. So cosecant square theta by 2 can be written as 1 by sine square theta by 2. So you get 1 by 4a sine power 4 times theta by 2. So this is my expression d square y by dx square. So you can very clearly see that this answer is also in terms of the parameter theta. So I hope you understand what we are doing. So at each stage you differentiate the function with respect to theta, but you divide it with dx by d theta extra. So that's how you go for higher derivatives in parametric functions.